Hello everyone, welcome back to BC Calculus. We're in lesson number 38, and in this video we're going to talk about reviewing how to graph polar functions. So in the next video we're actually going to do a couple of examples of graphing them, but for this one it's already graphed for you. I want to talk about relationships on the structure of the equations and what you should see visually in your graphs. There are three types of polar graphs that we're going to do in this class, and the first one is going to be our limicons, which is the inner loop, the cardioid, our dimple, and our convex. Where then we're going to talk about our circles, and then we're going to talk about roses. So let's go ahead and start with the special types of limicons, which is the inner loops, the cardioids, the dimples, and the convexes. So first thing I want to say about limicons is the fact that we have some number plus or minus some number, and then either sine or cosine theta. So that's the idea with this is. There's no 2 theta, 3 theta. It's just going to be a number plus or minus another number. And then again, sine or cosine theta. So what I always tell students to do is look at the relationship of A and B to figure out which of these types there are. You don't need to know specifically what they're called, just again, behavior of the graph. So the ratio of A to B is going to give you guys an idea of which of the 4 it is. The sine or cosine is going to give you what function, which axis is functionally dominant. So if it's cosine, we're going to be mainly on the x-axis. If it's sine, we're going to be mainly on the y-axis. The positive and the negative is going to tell you, well, in positive x or negative x axis, am I going to be more so on the positive or the negative side of y? So let's look at these exact examples and see what we can just kind of get out of them. So if you guys look at the first 2 examples here, the A is going to be less than the B. All right, which means if A is less than B, then the ratio of A over B must be less than 1, right? This has to be a fraction that's smaller than 1. So A is less than B, and that's the only case, if you guys look at the other examples here, this is the only case where A is less than B. So we're going to have an inner loop here. We're going to have an inner loop. So I want you guys to notice a couple of things about these numbers. Well, if you look first of all at cosine, the cosine's telling us that we're going to be on the x-axis, so our axis of symmetry is going to be on the x-axis. The other thing I want you guys to notice is that this is a positive, so we're on the positive side of the x-axis. If you were to add these 2 numbers up, and again, I'm not looking at the positive or negatives here. I'm looking at the number 1 and the number 2. If I add up 1 and 2, I'm going to get 3. Well, 3 is actually going to be the actual distance from the pole to the curve that's the furthest away. So this distance right here, like so over here, so I get 1 plus 3 is 4. So from the pole to the curve that's the furthest away, it's going to give me that value because 1 plus 3 is 4, and this is going to go 4 units. If I find the difference of those 2 numbers, so if I take 2 minus 1, I get 1, well, that's going to be the distance from the pole to the curve that's the closest. 3 minus 1 is 2, and I'm going to go ahead and find this right here, the distance of our smaller curve. I do also want to say that, this is just my silly little thing, that if it's A over B, this is less than 1. This is the tiny one. This is the one that's less than 1. So we're the baby. This is the little baby group. So I always tell students that this is the child that's inside the mom, right? So we have something inside of the belly. So the other thing that I want to tell you guys is that where it actually hits the other axis, so this is at 1 and negative 1, that's going to be your value of your A. Here, again, we're at negative 1 and 1, so this is going to be it. So this is going to have where we actually hit the other axis from. And we always come back to our poles. So that's an inner loop. Cardioid is special, it's a special type of limicon, where the A and the B are equal to each other. So it says, yeah, A over B has to be equal to 1, so they're equal to each other. So I always tell students that they're equal to each other. They love each other. They feel equal with each other. So you're going to have little hearts. You're going to have little hearts. So the first thing that we're going to notice here is that if I were to add the 2 together, just like I did over here, I added A and B, that's the distance of our curve from the pole to our curve, right? There's no 2 curves here, so we're just looking at the 2 numbers of these things. And I kind of wish this was written the absolute value of A plus the absolute value of B, right? That's kind of what this should have been written about, but that's fine. So that's how we find this. So again, I do 3 plus 3, that gives me 6. I also notice that I'm sine, so my function is dominant on the y-axis, and because this is positive 3, then I'm going to be up. I'm going to be up on the y-axis, so this is going to be 3. Just like over here, guys, the A tells us where we're going to hit the minor axes. So if I'm, for cosine, again, I'm negative, so then I'm to the left. So my non-dominant axis is going to be y. I'm going to go up 2. I'm going to go down 2 because of this number right here. This is 3, 3. And actually, it could be A or B. It doesn't matter because they're both the same thing. So that's how you graph these things pretty easily. So let's go on to our dimple. And like I said, it's not important to know these names at all. And you guys are going to start seeing a pattern here. You're going to see a pattern for this. So for the dimple, same thing applies really quickly. You know, cosine is obviously axis of symmetry is the x-axis. We're positive, so we're going to be more so on the right-hand side. If we add these two numbers up, so we get 5 plus 8, the distance from the pole to our curve is actually 8, right? This is 2, 4, 6, 8. The A value here, the number that's in the front, is going to be how far we go from here and here. So these are both 5 and 5. And then the difference of the two numbers is how far we're going to go on the other side. So this distance is 2. So 5 minus 3 is going to be 2. So if you guys look over here at this one, we have a negative sign. Therefore, we're looking on the y-axis, but more so in the negative direction. We add these two numbers up. We're going to get 3 plus 2 is going to be equal to 5. So we have 5 here. This gives us our 3. This gives us our 3. And then if we subtract the two numbers, we're going to get 1, which gives us our distance right here. And then, and like I said, to all of these things, all right, all the limicons, the first number is just going to be what's the distance from the pole to the one that's the minor axis. So again, if I look at cosine over here, my minor axis is sine, my y-axis. So if I go from here up, this is going to be 6, and this is going to be 6. For convex, it's the same thing as, these are kind of the same thing, ladies and gentlemen. So again, if you add these two numbers up, you get 6 and 3. That's the distance from the pole. This is 9. And if you subtract the two numbers, then you're going to get your distance right here, which is going to be 3. So for this one, we have 6 to the left, 6 to the right. We're going to go 6 plus 2 is going to be up 8. And then we subtract 6 minus 2, and we're going to get 4. So 8, 4, 6, and 6. And they're all the same thing. So this is all that kind of works out nicely for us in these problems. Another way of thinking about this one is on the other side, well, 2 minus 2 is 0. So this doesn't go out any further, right? The only one that's kind of important is that the little baby. So when A is less than B, then you're going to have 2 loops, right? We have 2 loops, and I've already told you guys how to do the problems with this. So it's kind of turned in on itself, right? Instead of being one this way, we flush it into the other loop. So that's going to be our limicons questions. Circles are probably the most direct ones because you're going to have some constant, and then you're going to either have sine or cosine. So the number is going to tell you how far the diameter is of your circle. So this ends up being 3, so this is going to be 3. The negative tells you the direction, and again, cosine, we're symmetric to the x-axis. So in the x-axis, we're 3 units to the left, and there you go. We have our nice, beautiful circle. And obviously, ladies and gentlemen, you guys can see that, you know, there's a circle here. We have a radius here. It doesn't really matter about the radius, to be honest with you. So for 5 sine of theta, again, sine, so we're symmetric to the y-axis. It's positive, so we're in the upper part, and then we go up 5 units. We are going to talk about, you know, how many rotations these graphs have when we start looking into the true calculus. But like I said, the point of this video is really just to make sure you guys can recognize and draw very quickly these graphs. So when we start doing calculus on them, you will actually have an idea of what you're graphing. And then the last example is going to be our, well, in this case, our petals. We're going to look at roses and stuff like that. But the radius is just how far from the pole it is. So if you were to look at the distance, like all of these are 3s. So all these distances right here would be 3. But the most important thing really is just how many petals you have. So you guys can see that if I have an even number in front of my theta, and that's an easy way of knowing that petals is going to be some number A and then sine or cosine of some B theta, right? So that's the idea, and I should have had that equation somewhere. So if we're in an even number, then we're going to double this number right here. So the even number is actually going to double what you see. And then if we have an odd number, then you're going to see that this is going to be 3, 5. So it's going to be the same. So again, this video is just showing you how to recognize equations, and then we're going to do some actual drawing of them in the next video. So I'm going to leave you guys be for this one, but remember now we have our rose petals, we have our circles, and then we have our fun little limazons. So I will see you guys in the next video when we actually start graphing some of these. I'll see you guys then.